I can choose a trigonometric ratio to solve for an unknown side in a right triangle. Today's about choosing. The last 3 lessons we worked individually with tangent, with sine, and with cosine, but today we have to figure out which one we want to pick. So the first thing we're going to do is what we always do, circle a reference angle, and then we're going to label the sides that they give us and the one we're trying to find. With opposite, adjacent, and hypotenuse, nothing there. And then you'll see we'll have to pick the correct equation. So we'll start with this one, and then you can try the others. My reference angle to start. Okay, you can see it's 65 degrees here. That's what's given to me. And the adjacent side is right here. And the opposite side is right here. Now I can go mark up the hypotenuse, okay, if I want. But it wasn't given to me. There's no number there. And it's not what I'm looking for. There's no x. So I don't really have to mark that up, so to speak. I don't want you to really look at it because instead I want you to realize what 2 sides are we working with. They gave us the 15, which is the opposite, and we're looking for the x, which is the adjacent. So, SOHCAHTOA, what uses adjacent and opposite? And the answer there is tangent. So the equation would be tangent of 65 degrees is equal to the opposite, 15, over the adjacent, x. Now you need to know what the tangent of 65 is, and we'll worry about that later. The key is, can you set this up? Again, all I did is I went back and I started thinking about SOHCAHTOA. Okay, so if you'd like, go ahead and try number 2 on your own. Okay, here I go. So I'm going to circle my reference angle. And I'm working with here the hypotenuse. I'm working with the adjacent. So I'm not working with the opposite. It wasn't given and I'm not looking for it. So what uses adjacent and hypotenuse? Adjacent and hypotenuse is cosine. So I'm going to go ahead and say that the cosine of 41 degrees is equal to the adjacent y over the hypotenuse 20. And I can go from there and solve it later once I know what cosine of 41 is. Let's keep moving. Here's the next one. You can pause it and now try it. Okay, here I go. Here's my reference angle. Let's see, what do I have here? Looks like they gave me the opposite. And I'm trying to find AB. Where's AB? Down here. That happens to be the hypotenuse. So if I were going to write an equation, I want something with the opposite and the hypotenuse, and that happens to be, according to SOHCAHTOA, opposite and hypotenuse is sine. So I'm going to go ahead and say that the sine of 82 degrees is equal to the opposite, which is 24, over the hypotenuse, which is just AB or BA. You can call it X as well if you really want. Okay, last one. Pause it and try it. Here I go. And you might be confused. Which one do I use? Well, actually we can use both. Doesn't really matter. Why don't we start with this one? If we say that this is our reference angle here, then you can notice how they gave us the opposite from the 21 degrees, while the hypotenuse is what we're looking for. So for us, that means we're going to use sine of 21 degrees because that deals with the opposite over the hypotenuse. But if you did it the other way, if instead okay, notice the x and the 9 are in the same places. Angles are in the same places. The only thing that's going to change, though, is my reference angle. What happens if I come from 69 instead? Well, then, what I care about is that 9 is my adjacent, and my hypotenuse is still the same. Okay? So now I'm working with the adjacent and hypotenuse. That did change. And for us, adjacent and hypotenuse would be cosine of 69 degrees is going to be the adjacent 9 over the hypotenuse x. both of these would actually help you solve for x just fine. Okay, so now let's move on to the next step. Now that we know how to pick which one we want to use, we're going to try and do it all at once and actually solve. So here, don't forget SOHCAHTOA at the top. Always, always, always. Then let's look at the first type of problem. Do the exact same thing we did, except this time we'll solve and we'll use whichever one of these we need. So here's 12, my reference angle. Turns out that's the reference angle here as well, which is good. Sometimes they trick you and they use the unknown one instead. And let's see what we have. Here's our hypotenuse. It looks to us like this is going to be the opposite. So opposite and hypotenuse. If I go up here to SOHCAHTOA, opposite and hypotenuse is right here for sine. So let's go ahead and write an equation. The equation would be the sine of 12 degrees is equal to the opposite x over the hypotenuse 35. Well, what is the sine of 12? Aha, there it is, 2/10. So I can go ahead and put this here, or if you prefer, you could have skipped right to this. And now everybody knows how to solve this. Just go ahead and cross multiply. You could reduce, but I'm going to hold off because I love dividing by 10, and that's what's going to end up happening in just a moment. So I'm going to get 10 times x is equal to 2 times 35, which is 70. And then I'm going to go to divide both sides by 10, and look what happens. Okay, just move that decimal point once, and we get x is 7. So that's the first type of problem. And I'm going to go do one more different type, and then you can try some check-ins. Look at this one. This one, they give you sine of 21 and sine of 69. So coming from both reference angles. The question is, which one should we use? Now notice, they didn't give us this side over here. They gave us this side here, and we want this side here. That's my find. So sine, we can only use sine. Which one, sine from 21 or sine from 69, will let us use both of these? And you probably guessed it, the answer is the sine from the 21 degrees. Because here's our opposite, what we're looking for, and here is the hypotenuse. So now we can say sine of 21 degrees is equal to the opposite over the hypotenuse. Now if you did 69, sine would be opposite over hypotenuse. So you'd be finding this side over here instead of this one here, and that's not what you'd want to do. Let's go ahead and substitute. Sine of 21 is what? 36/100. Well, now we can go ahead and write that 36/100 as a fraction. I notice I love getting 100x, so I'm not going to reduce first. We get 100x. 9 times 36 I might have to go do. That's going to be 180 and 56, so I think it's 236 if I have it right. And then when we divide both sides by 100, we luck out. We can move the decimal point twice. And we're good to go. So you can try your hand at the next two, both of these versions. Okay, with a check-in. All right, hit pause if you haven't started. Here I go. Here's my reference angle, and I'm trying to find AC. That's what I'm looking for. It's my find. So I'm not done until I have that. So let's see. If that's what I'm looking for, that seems to be the adjacent to 55 right there. And they gave me 71. That's the opposite. So what uses the opposite and the adjacent? If you go to the top and look at SOHCAHTOA, that's going to be tangent. So we're looking for the tangent right here. So we can go ahead and write it out. Tangent of 55 degrees is equal to the opposite 71 over the adjacent AC, or you could call it x if you prefer. Tangent of 55 is really 1 43/100. Let's rewrite this. This is really 143/100. And now it looks like we have a numeracy issue. We have a lot of stuff going on here. So I can go ahead and cross multiply, and it's just going to get heavy, and that's okay. I can't reduce this as far as I can tell. So this will give us 143 AC is equal to 7,100. So now you have to divide both sides by 143. And you're looking at AC is equal to whatever that is. Yikes, that's a lot. Well, it's going to take some serious long division, probably on a piece of scratch paper. Let me see what I can do over here, though. Doesn't go in, doesn't go in. And how many times would it go into 710? I'm going to guess about 4 times. Let me guess 4 times. I'll have to go off to the side. 4 times 143. That's 12. That's 16. That's 17. 4. That's 5. That's 572. It's pretty close. If I add one more in, let me see. What's 572? If I do one more 143, that's 6. 15. So yeah, that'd be too much. This is right. 4 times was right. The answer is 572. And the difference there is pretty big. You're going to have to get, let me see, borrow this guy. 10, so that's an 8. Now I need help here, so 6 and 10. That's 3, 1. 138, yikes. Okay. And now we bring down the 0, and we have to figure out how many times it goes into 1,380. Man, this is getting heavy. So this really needs to be done on another sheet of paper to be sure. I'm out of room, but I'm going to go ahead and speed this up for just a second and go to the trusty calculator and just quickly do 7,100 divided by 143. We get 49 and 65 hundredths, but I want to round to the nearest tenth if I can. So I'll say it's approximately equal. There we go. All right, I'll have to leave more room next time. So next up, you can go ahead and try this one now, a little more reasonable. Now you can hit play when you're ready. Okay, so which one will I use? I have to use cosine, that's adjacent, and hypotenuse. Well, the adjacent to this one, there's nothing there. I'm using these two. So this is the one I want. That's my reference angle. So I'm going to go ahead and use my adjacent and my hypotenuse. And that way I'll have cosine of 37 degrees. In this case is equal to what? It's equal to x over 13. But cosine of 37 is 8/10. Go ahead and cross multiply. You could reduce, but I want to divide by 10 later, so let's see, that's going to be 80 and 24 is 104. Let's divide both sides by 10, move the decimal point, and therefore x is equal to 10 and 4/10. A little more reasonable, that one, than the other. Okay, very last thing. If you take a look down here, are there any of these that we couldn't use? So notice we have both reference angles. Any of those that we couldn't use to find x? Okay, so if you've paused and thought about it, well, the answer would be tangent. Anything with a tangent, and you can tell why, because tangent is opposite and adjacent. Tangent is opposite and adjacent. If you use tangent, you're never going to use the x, which is what you're really trying to find, the hypotenuse. So you don't want to end up using tangent. Okay, good luck, be patient,